Hey guys, so today we're going to continue with some work with fractions. Yesterday you should have re-watched the fraction lesson that we last did together, talking about unit fractions and how to label our fractions. So just to do a quick fraction review, we know that fractions are part of a whole. If you have a piece of notebook paper or your math notebook, this would be a good thing to be writing, just like if you were in class. If I am writing, you were writing. If you need to pause to catch up, by all means, please do that. We also know that most fractions have a TH sound. So for example, if I'm reading 1/4, it's going to sound or look like this. That TH signals that this is a fraction, 1/4. Now, there are some exceptions to that. 1/3 does not have a TH at the end, and 1/2 does not have a TH on the end. But most of our fractions that we're going to be dealing with in 3rd grade have that TH, and that's a language symbol, just so we know that this is definitely not a whole piece. It is a part of a piece. We know that a numerator is the top number in our fraction. So in this case, 1 is the numerator. It tells me how many pieces I have. So in the example of 1/4, I have one of the pieces that it's partitioned into. The denominator, which in 1/4 is our bottom number, tells me how many pieces it's partitioned or broken into. So with the fraction 1/4, if I'm imagining a cookie or some kind of model, I would have 4 equal size pieces. Fractions are fair. So I'm going to make my 4 equal size pieces. And then the numerator of 1 in the 1/4 fraction tells me that I have one of those pieces. When I look at this and I think about what we've done with fractions on a number line, if I only have one out of my 4 pieces to get to a whole, this number is probably going to be closer to 0. I am closer to having no pieces than I am to having all 4 pieces. So that was just a quick review of some of the things that we've already covered so far. This should be knowledge you know. If you're still confused on any of these things, go ahead and pause this video, head back to yesterday's video. You can go back on my actual website under math videos and rewatch some of those as well. Alright, so today we're going to be looking at this problem. It says Josh and Ashley both ate 2 slices of cheese pizza. Each pizza was cut into 6 slices. Ashley ordered a small pizza and Josh ordered a large pizza. Illustrate each person's pizza below. So what I want you to do is go ahead and make an Ashley pizza section on your notes and a Josh's pizza section on your notes, and draw what that might look like. Alright, so I know Ashley ordered a small pizza, so I'm going to draw a small round pizza. Again, I know I've told you before that I'm not a big fan of round models. I choose round because pizza is normally round, but if you feel more comfortable doing rectangles because they're easier to make fair size pieces, go for it. Josh ordered a large pizza, so I'm going to make that really big. If you didn't make your pizzas 2 different sizes, go ahead and fix that now. Both pizzas were cut into 6 slices. In order for me to do that, I need to partition them into 6 slices. Alright, so each pizza is partitioned into our 6 total slices. The very first sentence is they both ate 2 slices. So what I would like you to do is color in the section of the slices that they ate. So my red is going to represent the pieces of pizza that each person ate. Alright, now we need to figure out the fraction of the pizza that each person ate. So let's look, I like to start with my fraction bar. I'm just going to draw over here. Go ahead, and if you can create the fraction for each person, go ahead and write that fraction of what pizza they actually ate next to the model that you've drawn. So we know that both Ashley and Josh, their pizza was divided into 6 equal slices, which means 6 would give us the total. That's going to be our denominator. So both of these are actually going to have the same denominator because they're both split into the same amount of pieces. They both ate the same number of pieces. So the numerator is how many pieces they ate, which is 2. Whoa, it's the same fraction. So I want you to look at this last question of did they eat the same amount? I want you to go ahead and write that question and then take a few minutes. You can pause the video and answer that question both in your notes and I'm going to have you type it as well. What do you think? Did they eat the same amount? So I hope by now you got some thoughts down on the paper and you were able to kind of justify what you were thinking. While I noticed they definitely had the same fraction, which might lead me to think that they ate the same amount, when I look at my model, if someone is eating a gigantic pizza, that's much more pizza than a small pizza. So no, they did not eat the same amount. If you did not put that in the typing form, that's okay. That's just a chance for me to see what you were thinking, just like if we were in class. It's not right or wrong either way. I'm just trying to gauge what your thought process was. If you did not write this on your notes, however, I would like you to change that on your notebook that you're doing this on. Alright, so now we're going to work on a couple of additional word problems. I would like you to solve them on your paper. I will pause the video and kind of jump in and give some guidance along the way, but for the most part, these are going to be on your own. So the first problem reads, Caitlin and Penelope both ate 1/2 of an apple pie. Caitlin's pie was small. Penelope's pie was large. Illustrate, aka draw, each girl's apple pie below and write the fraction that your picture represents. Very similar to what we just did. Moving down to the second problem, it says Fernando and Harmon were both 8. Ooh, that doesn't make any sense. Fernando and Harmon both ate 2 pieces of a sub sandwich. Fernando ordered a 6-inch, aka a small sandwich, and Harmon ordered a 12-inch, aka a large sandwich. Each sandwich was cut into 4 pieces. Did they eat the same amount? Explain your thinking and prove it with a visual model. So again, very similar to this idea of we have the same fractional piece. Each kid ate the same fraction amount, but does that mean they ate the actual same amount? Alright, by now you should have done the Penelope problem and the Fernando problem, and you should start to notice that when we are comparing fractions, the wholes must same. It is not fair for me to compare a small pizza to a large pizza. It is not fair for me to compare a small sub to a large sub. I can't correctly compare them because they didn't start out the same. So if we are going to compare fractions, if we're going to try and figure out who ate more or who ate less, or which fraction is larger or smaller, then we have to make sure that we're fair from the beginning, and we have to make sure our models are the same from the beginning. So going back to the very first problem that we did, if they had both ate from a large pizza, we could compare what fraction they ate because the whole was the same from the beginning. Even though both the small pizza and the large pizza were split into the same number of pieces, those pieces were not the same size, and we can't compare things that are so different. Fractions are fair.